Welcome to the lecture series on numerical methods, finite difference approach. In this approach, we have discussed like elliptic equations, parabolic equations, hyperbolic equations and their solution techniques. In the present lecture, we will discuss about this characteristics of a partial differential equation, then the significance of characteristics, and afterwards we will just go for like solution of hyperbolic equations with examples. So, if you will just go for this characteristics of partial differential equation. So, usually we are just writing the second order partial differential equation in the form as a del square u by del x square plus b del square u by del x del y plus c del square u by del y square plus e equals to 0, where especially a, b, c and e are functions of x, y, u, ux, uy. Generally it is just expressed in this form. So, if you just write this expressions in the notations as p equals to suppose del u by del x as ux here, and q as del u by del y, which is just defined as uy here, and r as the second derivative term, that is especially del square u by del x square, that is nothing but del by del x of del u by del x. So, that is why it is just written as del p by del x here. S, which is defined as del by del x of del u by del y, which is nothing but del p by del y or del q by del x. So, you can just write, and if you just write t terms here, so t can be written as like del square u by del y square, that is nothing but del by del y of del u by del y, that is nothing but del q by del y here. So, if you will just write it in complete form, then it can be expressed as ar plus bs plus ct plus e equals to 0. Suppose a curve like G be a curve which is defined in a domain D, where this partial differential equation holds. So, assuming that suppose u, ux, uy are continuous functions in D, and along this curve, if you will just consider like dp equals to del p by del x into dx plus del p by del y into dy. This is as since we have just defined r as del p by del x and s as del p by del y. So, you can just write this one as r dx plus sty here. And similarly, if you just define here as dq, that is del q by del x into dx plus del q by del y into dy here, which can be defined as sdx plus t dy. And if we will just express this partial differential equation is satisfied at each point in the curve G, which is defined inside this domain D. So, if you will just put all these values of r and s from like first equation in the complete form, then we can just write this one as, since it is just expressed as r, ar. So, that is why r can be written as like dp by dx minus s dy by dx plus bs, especially if it is like that way, it is just present there, c into t, especially t can be replaced as like dq by dy minus s dx by dy plus e equals to 0 here. And in a compact form, if you will just express this equation, then it can be written as a dp by dx plus c dq by dy plus e minus s a dy by dx minus b plus c dx by dy, this equals to 0. And if you will just multiply dy by dx at both the sides, so it can be expressed as a dy by dx a dp by dx plus c dq by dy plus e minus s. Since dy by dx is multiplied, so it can be expressed as a dy by dx whole square minus b dy by dx plus c. Since it is just cancel it out, since dy by dx into dx by dy, so that is why it is just coming as 0 there. So, if the curve G, which is satisfied by the solution of this equation as a dy by dx whole square minus b dy by dx plus c equals to 0, we can just consider this left hand part of this equation as 0 there. So, if you just put this one as 0 here, so we can just write dy by dx into a dp by dx plus c dq by dy plus e equals to 0. And obviously, if you will just multiply this term in the equation, then it can be expressed as a dy by dx into dp by dx plus c dq by dx, since especially dy it will just cancel it out, plus e dy by dx, this equals to 0. So, if you just see here, this can be written as like in a differential form. If you will just express, this can be expressed as a dp by dx into dy plus c dq plus e dy, this equals to 0. And if you will just solve this equation that is expressed in 18.6 here, that is a dy by dx whole square minus b dy by dx plus c equals to 0. This is a quadratic equation here, and its root can be expressed as dy by dx equals to b plus or minus square root of b square minus 4ac by 2a here. And if you will just go for the solution of this characteristic cos, which is just defined on this curve g in xy plane, if a, b, c are constants or functions of xy, then the equation of cos can be explained it in explicit form. And if you just go for this like equation of 18.8 here, so which is just expressed as a dy by dx form here, so that just gives the direction of this characteristic cos at the point xy of g there. So first condition, if you just consider here as b square minus 4ac suppose less than 0, so then there does not exist any real characteristics there, that is in case of elliptic equations. So especially this is the condition that is justified in case of elliptic equations, there will be no real characteristic cos. And if you will just consider like b square minus 4ac equals to 0, then that will just represent the parabolic equation form. And if you will just see here, this can be justified for a single characteristics there. So we will have like one characteristics there. But if you will just go for b square minus 4ac greater than 0, then this equation 18.8, it will just provide two real characteristics. That is in case of hyperbolic equations, there will be two real characteristic cos there. So if you will just go for this significance of this characteristic cos there as a solution of like a linear partial differential equation, it should be unique at any point, and this region is enclosed by an initial curve c and have a characteristic curve there. In case of parabolic equations, we will have like a equals to 1, b equals to 0, c equals to 0 there, since we have to show that b square minus 4ac equals to 0 there. So in that case, if you just put all these values, then we can just obtain this dy by dx, which is defined as like minus b plus or minus square root of b square minus 4ac by 2a, that can be taken as a 0 value there. And if you will just find the solution of this equation, that is especially nothing but y equals to a constant there. And if you will just go for this region of determinancy of solution in case of parabolic equation, is the region enclosed by the initial line, that is y equals to y0, and the characteristic curve that is just defined by this constant function y equals to yc there in the xy plane. And if you will just go for this hyperbolic equation sense here, so this hyperbolic equation, especially if you will just write a generalized hyperbolic equation, so it can be expressed as a del square u by del x square, this equals to del square u by del y square, or in generalized form we are just expressing this one as a del square u by del t square, this equals to del square u by del x square there, where we are just writing a equals to 1, b equals to 0, c equals to minus 1. So that the characteristic curve will be given by as a dy by dx, this equals to plus or minus 1. We will have two solutions here. So if you just change this variables y in forms of t here in the xt plane, then we can have the solutions like t equals to x plus a constant, and another solution that will be minus x plus a constant there. So if we will just denote it in a figure, suppose OA denotes the initial curve c, on which appropriate boundary conditions are suppose prescribed, then the region of determinancy is given by like OB, A, B dash, O there. So there are two characteristics at each of the points O and A, which is just given in the form of y equals to x plus constant, another one is y equals to minus x plus constant. So if you will just determine this two characteristics, so one it is just defined as at the point O, another which is defined at the point A. So this can be just represent in this form here. That is especially the region of determinancy of hyperbolic equations. And if you will just go for this like characteristics for solving this hyperbolic equations, so referring to the general form of the second order partial differential equation, which is just defined in the beginning of the slide, and assuming that it should be hyperbolic in form, then the two characteristics are as like dy by dx, this is just expressed as like b plus square root of b square minus 4ac by 2a, 1, and another one it is just expressed as b minus square root of b square minus 4ac by 2a. which is just written in this form. If you will just signify this first function as f here and second function as g here, where f and g are functions of, you can just consider as x, y, u, ux or ui there. So, if you will just consider this domain is extended between like a open space like a xy plane. So, which is just defined from minus infinity to infinity in the xy plane, then we can have the values like u, ux, ui are defined along this curve, and to determine these points. So, if you will just go for like different steps, the steps can be like described as follows here. So, first step we will just choose these points like on the curve here, that is characteristic grids we can just form, and suppose if you will just choose these points like a, b, c, d, which may not be equidistant if you will just consider in a regular domain on the given curve, and denote their position. Suppose a is like x a, y a here, and b is like suppose x b, y b here, and c is like x c, y c here, and d is suppose x d, y d here. And then we can just draw these characteristics through these points a, b, c, d, and if f and z, suppose which is just expressed in the equations like 18.12 here, that is one is just taking like b plus, another one is just taken as b minus there, which just involves only x and y, then the equations of characteristics can be drawn as shown in the figure as here. That is af the f characteristic and az is the g characteristics, so which is just defined at the point a. So, likewise we will have this characteristic at the point b like bf and bz. If you will just find here f and z involves this u and its derivatives, then exactly we can find the location of intersection points, namely like if you will just see here, that is the points as r, s, t here. So, to determine these points here, we can just integrate this equation like 18.12 from like a to r here. If you will just see point a to r, yes, this one. So, we can just integrate this differential equation there. So, that will just give you like yr minus ya, this equals to fa into xr minus xa there. Since this equation, if you will just see 18.12 here, yes, this one dy by dx, that is nothing but defined as function f here. If you will just integrate simply here, so integration of dy, we can just write this one as integration of f dx. Since the point it is just defined at the point a itself there, so that is why this functional value we can just assume this one as fa there, and this integration dx that is just varying from xr minus xa there. And similarly, if you will just integrate a equation like 18.13 from b to r, we can just get it as like yr minus yb, this is equals to gb into xr minus xb there. So, by solving these equations like 18.14 and 18.15 here, we can get the coordinates of r, that is as xr, yr of the grid point r there itself. To find the solution to the grid points ub, the values of u, ux and ui will be required at the grid points like r, st. So, for that we will just solve these equations, that is in the form of like a dy by dx dp plus c dq plus e dy equals to 0. And if you will just go for this integration of 18.16 equation here, so then we can just find here a dy by dx, that is nothing but it is just defined as the function f there. So, that is why it can be taken as a fa, and this integration range that is just varying dp integration, that is why we have just considered as a pr minus pa there. Then if you just say, so c dq means q range is just varying from r to a there itself. So, ca qr minus qa plus E is the point defined at the point A there itself. So, EA plus dy is the range. So, yr minus ya, this equals to 0 there. And similarly, if you will just integrate this equation 18.16 from B to R along the characteristics curve G, we can just get this one as like AB, FB, PR minus PB plus CB, and QR minus QB plus EB YR minus YB there. So, same way just the point has been just getting it changed. So, by solving these two equations like 18.17 and 18.18, we get the values of PR and QR. To find the values of U at the grid points like R, that is UR, we can just use this formula, that is as a du equals to del u by del x into dx plus del u by del y into dy there, where if you will just find the solution here, U is nothing but P dx plus Q dy, and obviously if you will just integrate this equation from A to R along the characteristics curve f, or from B to R along the characteristics curve G, we can just get UR equals to UA plus PR plus PA by 2 into XR minus XA, that is the distance from like point A to R in the x direction. And if you will just write for this Q position there, so it can be written as QR plus QA by 2. So, we are just considering this average of two values there, if you will just see the curve there. So, A and B it is just considered, and both these curves that are just intersecting at the point R there itself. So, that is why we are just considering PR plus PA by 2 there. And similarly, since both these curves they are just intersecting at the point like R and A for Q value also. So, that is why we have just considered QR plus QA by 2 into YR minus YA there. After getting the approximate values of grid point R here XR to YR and UR, we will improve these values by modifying the steps 2 to 4 as follows. Since the values of f and z as computed like at the points R also, we modify it by taking the average values, that is like YR minus YA. If you will just consider, since earlier we have just considered as FA there, so which is just nothing but the average we have just considered as FR plus FA by 2 into XR minus XA here. Similarly, if you will just go for like YR minus YB, so same point if you will just consider here along the curve G there, so you can just write that one as a GR plus GB by 2. So, that will just take this average of a G function at that point, so into XR minus XB. And if you will just solve these equations 18.21 and 18.22, we get the improved coordinates XR YR of this grid point R. Similarly, we can just modify like step 3 if you will just see here by taking this average. So, we can just write this one as like A plus AR by 2 into FA plus FR by 2, since both these functions we have just written in step 3 here, that is like A FA PR minus PA plus CA QR minus QA plus EA YR minus YA, this equals to 0. So, each of these points that are just changed by this taking these averages here. So, PR minus PA itself it is just there, then CA is replaced by CA plus CR by 2, and similarly EA is replaced by EA plus ER by 2 here. And similarly, if you will just replace like a second equation of step 3, so that is nothing but like AB FB PR minus PB plus CB QR minus QB plus EB YR minus YB there, this equals to 0. So, that is why this EB is replaced by EB plus ER by 2, CB is replaced by CB plus CR by 2, and here we have like this is nothing but GB. So, GB is replaced by GB plus GR by 2 there. So, if you will just solve these equations, we can get the improved values of PR and QR there. In the same way, U can also be modified by using the list values of all these parameters like XR, YR and PR and QR. And if you will just write this one, we can just write in a improved version here, that is UR equals to UA plus PA plus PR star. Since star just we are just denoting this one as the improved values obtained in step 5 and 6 for this like PR star and QR star here, and XR star and YR star here. We can just iterate this procedure by repeating like steps 5, 6 and 7 to get the further refinement of these values here. So, based on this, if you will just go for a practical example here, so we can just visualize that how clearly just this characteristics and the point of intersection we can just get it out. So, suppose this example we are just considering as like a function u is a solution of this equation del square u by del x square plus 1 minus 2x del square u by del x del y plus minus 2x del square u by del y square plus x equals to 0 suppose. With the initial condition u equals to x and del u by del y equals to 0, where your x plane is lying between like x line is lying between minus infinity to infinity and y equals to 0. So, the question is asked to calculate u at the point r, which is the intersection of the characteristics through the points a at the point 0.20 and b, which is just defined as 0.40 on the initial curve y equals to 0. If you just consider this coefficients of this characteristic equation here, this coefficients can be written as like a equals to 1 from this coefficient here and b as 1 minus 2x, since this is nothing but ar. So, bs. So, c is nothing but minus 2x here and e is nothing but x here. So, we can just define u as the function of x here, since the initial condition it is just given as x here, and if you just take the first partial derivative, so ux can be written as 1 and uy equals to 0. So, the characteristic curve if you just write here, so that can be written as a dy by dx whole square minus 1 minus 2x into dy by dx minus 2x equals to 0. So, if you just find the roots, so that can be written in the form of dy by dx equals to 1 minus 2x plus or minus square root of 1 minus 2x whole square plus 8x by 2, and which can just provide the value 1 or minus 2x. And if you just consider like dy by dx equals to 1, which is f here, and dy by dx equals to minus 2x as z here, then the solutions we can just get it as like on the f characteristics at 0.20 as y equals to x minus 0.2. Since we are just considering here as if you just see this integration dy along this x here. So, this range is varying if you just see the yr minus ya, this is nothing but fa into xr minus xa there. So, that is why it is just taken the values as y equals to, since 0 is the point here, y minus y0 especially it can be considered as x minus x0, so x minus 0.2 here. Similarly, if you will just find the solution for second equation here, that is a minus 2x into dx, so its integration will be minus x square here. So, if the point is varying like from 0.4 to 0 here, so y equals to minus x square minus this 0.4 whole square, that is nothing but 0.16 here. Since this differential equation is satisfied along this characteristics, so we can just write this one as a dy by dx into dp minus 2x dq plus x dy equals to 0. So, if you will just follow the steps like points a as 0.20 and b as 0.40 on the initial curve is already specified, and points of intersection of f characteristic through point a and g characteristic through b is obtained by solving like equation 3 and 4 here, which is given by like the r coordinate as xr yr, where xr equals to 0.281 and yr as 0.081 here. And if you just follow here equation 5 here along f characteristic after using equation 1, we can just get it as like dp minus 2x dq plus x dy equals to 0. And if you just integrate this equation from a to r, we can just get this one as like dp, that is nothing but pr minus pa minus 2 into xr plus xa by 2, we are just taking the average here, and qr minus qa plus xr plus xa by 2, x is the average we are just considering, and dy integration it is just varying from a to r. So, that is why it is just considered as yr minus ya equals to 0 here. And if you will just put all these points here, so we can just write this one as like this point as 1 and 0 especially we are just considering, if you will just see. So, that is why it is just written as like pr minus 1 minus 2 into your average points we have already computed here as a 0.281, and 0.2 it is just given there. So, by 2 into qr minus 0 plus 0.281 plus 0.2 by 2 into 0.081 minus 0, this equals to 0, where if you will just solve this equation, so this is just taking this form pr minus 0.481 qr, this equals to 0.9805 here. So, if you will just go for this equation 5 along g characteristics after using equation 2, it can be represented as like minus 2x dp minus 2x dq plus x dy equals to 0, which is nothing but 2 dp plus 2 dq minus dy equals to 0. If we will just integrate this equation from b to r, we can just get this equation as in the form of pr minus pb plus 2 into qr minus qb here. So, minus yr minus yb, this equals to 0, or pr minus 1, since pb is considered as 1 there, plus 2 into qr minus 0 minus 0.081 minus 0, this equals to 0. So, pr plus qr, this equals to 1.0405 here. So, if you will just solve like equation 7 and 9, so this is two equations involving pr and qr there, we can just get the solution as pr equals to 1.0 and qr as 0.0405 here. Again, if you will just integrate this equation du equals to p dx plus q dy from a to r along f characteristics, we can just get this equation as ur equals to ua plus pr plus pa by 2 into xr minus xa plus qr plus qa by 2 into yr minus ya here. And again, if you will just integrate du equals to this one from like p dx plus q dy from a to r along f characteristics, we can just get it as ur equals to ua plus pr plus pa by 2 into xr minus xa plus qr plus qa by 2 into yr minus ya. And if you will just put all these points, so we can just get ur as 0.2826. And one note we are just providing here, if integration is done along g characteristics from b to r, then we can just get ur as 0.2826 here. So, steps like 5, 6, 7 are not required, as all parameters are independent of u, ux and ui here. Thank you for listening this lecture.